Hey, so now we are going to see a very important session that is called the standard deviation. So, every person who learns a Six Sigma should be able to say what a standard deviation means. So, in statistics, there are three important aspects of measurement is there. One is average, which is called the mean. The second is the mode, and the other one is called the median, right? So median is something that which is available in the center of a data, and mode is something that which comes several times. But out of all, mean is a very important standard, which we also call that average, which we are supposed to know, and I'm sure everybody knows about it. Now, what is the standard deviation? A standard deviation is talking about how far my data is from the center, from the mean. If you see the picture below, it's called the mean, otherwise, it's called the mu, is at the center point. If it is the center point, there are plus or minus here at this picture. If you see, it's plus 2 or minus 2, or plus 4 or minus 4. It is either left or right, okay, and it is away from the center point. And what is our requirement? We need to bring all the data towards the center point. So the standard deviation talks about how far we are from the center point. Okay, let us take this example as I used every day. You start from your house to the office and reach exactly within 30 minutes. Say you're supposed to report to the office at 9 o'clock, and you start home at 8:30, and you predict in 30 minutes I will reach the office by 9 o'clock. And you're, if you calculate last 100 days, and you're confident enough, in 30 minutes I've reached the office, which means 30 minutes is your average, isn't it? Sometimes you reach in 35 minutes. Sometimes you reach in 25 minutes, right? So there's a plus of 5 minutes here, right? Plus 5 minutes or minus 5 minutes. Sometimes you reach plus 10 minutes, minus 10 minutes. What that means? You're reaching 10 minutes plus or minus, which means you're 10 minutes away from the center point. So the more you go away from the center point, that means that your standard deviation from the center point is very far. That is why we say here, right? A higher standard deviation is not good. Your values are spread out. Your performance is less consistent. You have a more defects. So you have to strive to bring your standard deviation to the center, and it is less. How many times my invoice getting rejected every month? So if you convert the standard deviation into lesser, like I said, you're going to the office in 30 minutes, and your standard deviation is always between 5 and 10 minutes, you can always predict you can reach office between 25 and 35 minutes. Do you understand that? Right. So here we got a formula, which is the sigma. Standard deviation is nothing but the sigma. So it the formula basically states as x minus mu the whole square divided by n. As you see the two graph, the green color, which is low standard deviation, and the red is the high standard deviation. Which you think is better? The sigma which has got a low standard deviation is better. Don't go for the biggest standard deviation. The variation is very high. In the property management, I see the energy bill every month. It is always in a big standard deviation. One month my unit is 100. One month my unit is 1000. One month it is 500. One month it is 300. And when I see the standard deviation, it's somewhere around 200 to 300, which is not acceptable. Your standard deviation has to be less. It should be average. It has to be close to the average. Look at the real life examples of facilities management, the complaint resolution time in hours, right? The standard deviation is 0.55. Look at that. You see this, which I'm showing this, my arrow mark. Whereas there's a high standard deviation of 3.42. My achievement is to receive a standard deviation of 0.55. But 3.42 is away. So let's work towards a smaller standard deviation. To know how to calculate standard deviation, I recommend to see my videos in my YouTube about how I have defined how I can make a standard deviation in the Excel and what is standard. Don't miss that video. You love it, learn it, because a yellow belt or a green belt, a must is to have a standard deviation calculation to be understood, right? So, what is a normal distribution? As I said, a normal distribution is a bell shaped and a symmetrical around the mean. It should be like a bell. If your data is clear, it should be like a bell shaped. A key center property, your mean is equal to median, is equal to mode, will be in the center. Then it is a normal curve. It is called the 68, 95, 99.7 rule, which means that 68% of your data falls within plus or minus of one standard deviation. I told you, when there is an average, the plus or minus one, 68% of your data falls between one standard deviation, 95% data within two standard deviation, 99%, 99.7% with a three standard deviation. Got the point? That is how the normal distribution works. Let's look at here. Very systematic graph. You all need to know the normal distribution. You must be thinking, oh, this is a statistics. I don't want to learn this. I'm telling you, this is very easy. And if you're able to learn this, you can make wonders in your daily work. You can make wonders in the process, right? So as you see, the variations, it says the center of the mean plus or minus 1 is about 68%, and 27% the plus or 2 minus sigma, and it is 3 sigma away from the standard deviation. So it's a very simple. Low standard deviation, the process is good. High standard deviation, opportunity improve. Okay, don't forget. So as you see, we have done a good, helped us to get closure time. So there are certain things you need to learn here. That is LSL, that is the lower specification limit. USL, upper specification limit. Mu, average, that's mean. So let's take, for example, an help desk ticket. Okay. For closing a help desk ticket, the lower specification limit is 20 minutes. The upper specification limit is 45 minutes. And when you commit to your client the KPI, the client says that every ticket I want to close, I want to close between 20 and 40 minutes. So what happens? I make a process with a 20 lower specification limit and 40 specification limit for upper, and the process spread is between 20 minutes and 40 minutes. Now, what is my mean? Mean is 30 minutes because maximum number of time I finish between 25 minutes and 35 minutes. So what that means, I can always finish my work between 1 sigma plus or minus. If I'm able to finish all the thing plus or minus 2 sigma, which is 20 LSL and 30 LSL, you're in a 3 sigma process because the shift happens 1.5. 1.5 into 2 is 3 sigma. So when your lower specification limit and upper specification limits stands here, I'm just pointing my arrow. So here between this and this red dotted line, if you're able to finish, it means that you're in 3 sigma process. But if you always finish your specification limits, so we call this as a control limit. If you put a control limit between 20 and 25, 35 and 40, and you always have a buffer in between, then you work towards 6 sigma. Look at the process of a 3 sigma process. There is a 30 minutes, 15 to 45 minutes is your process graph. It is wide, your 3 sigma, this is 1 sigma, this is 2 sigma, this is 3 sigma. Your process is big enough, you're in 3 sigma. But a 6 sigma process, a process spread is 60 minutes, 0 to 60. The center is spread from 0 to 60, but still your control limits is only in the center. Still you have a higher chance of not making a mistake, which means you're doubly capable, and you will know that you're in a 6 sigma process. The process spread is 60 minutes, 0 to 60 minutes, but always you close between 20 and 40 minutes, you're a 6 sigma process. Okay? Please look at my video, it will be easy to understand. Next, we are going to Kano model. The Kano model has got three different aspects. One is stated needs, one is unstated needs, and one is delighter. Always a delighter creates a wow experience. A stated needs is a basic, it's a KPI, right? Unstated needs is performance. Customer explicitly asks for this requirement. I want this. I want 100% manpower. I need 100% uptime. I need a zero incident. This is a stated needs required by the clients. But there are certain things they don't even ask you, unstated needs. For example, compliance. I don't have to ask you. Compliance is a mandate. A better performance steadily increases the satisfaction and loyalty. And the next comes the delighters, a wow experience. I've made a video also for the Canon model. Have a look. So as you see, this is my Canon model. Consider any process external to customer, who is the customer, and the quality characteristics. As you see, these are all stated needs. I told you, what does the client expect? He expects the safety and the security. These are all we seen in the KPI. Remember y equal to f of x. And these are understood, unstated needs. Customer need not say this. It is an expectation. Feeling of safety at all times, 24 bar 7. Trust that assets and data are secure. Compliance with the safety regulations. Train the staff. Preparedness. Start doing your unstated. Don't allow clients to ask what they need. Start working on unstated needs first. Then comes the delighter. When the client says, wow, that's the way, that's what the organization wants, that is what I need to do. We need to work on wow factor. Okay, so corner model design is a basic need. The performance need to be better, make exciting things unexpected value, absence usually not noticed, and prioritize must be first, then optimize the performance, add delay. This is how you need to start working and corner model. You can do a projects on this. This is the quality approach. How do you do a quality? Do a inspection, do a QA/QC, and do a Six Sigma process. Always Six Sigma process is an improvement parameter. It is a preventive action. It is a predictive action. It is a continuous organization-wide approach. Yeah. So now we are coming to very important aspect. Is called the RCO and ICD. Okay, what is RCO? RCO is the reduce occurrence. Okay, as one more word, you need to, everybody has to write it down. It's called the FMEA. What is FMEA? It's called the failure mode effect analysis. Every person has to start working. How I will first identify what a failure can happen, when a failure can happen. Let's take an example. You go to office today and somebody is working today, and what are the failures can happen? Some by mistake, a proper work report in a work method statement is not done, or an incident reporting statement is not done, and it will lead to an incident management. So RCO prevents the causes. ICD reduces impact after defects happen. Use both for stronger reliability. The primary objective of RCO, reduce occurrence, let it not happen at all. In other ways, we call this POCO-OK. So you probably must have seen, like in your mobiles, the mobiles which comes used to be 5 years or 4 years back. I don't know. These mobiles today doesn't come with this technology. But before, when I used to use, when we buy those SIM cards, always the SIM cards has got a cut on the side. What does it mean? It doesn't allow users to put the SIM card in a different direction, right? You have to fit in the right place. So prevent occurrence. Don't allow mistakes to happen. Do a error proofing method. That is a requirement of an RCO. Standardize the work, maintain before failures, build capability, design without mistakes. Apply Pocoyoke and it will be a great method. RCO prevention examples in HVAC operations, schedule preventive maintenance to avoid unplanned breakdowns, track PM compliance, housekeeping used standard checklist, critical assets, routine inspections, process control, procurement, everything reduce the occurrence. Don't allow a mistake to happen. That is what RCO basically means. ICD is very important also. It is find defects early, okay, before customer feels the impact. So there is two things very important, which is internal and external defect. What is an internal defect? An internal defect is something which happens inside our office. which the product does not go to the client. But if it goes to the client, it becomes an external defect. Any defect happens external. For example, we don't check something, it goes to the client as a defect, like your invoice. It goes a defective invoice to a client, error invoice. Then what happens? You lose your credibility with the client. So ICD is very important. Two important thing we spoke: RCO, reduce chance of occurrence; ICD, increase chance of detection. I spoke to you about some examples, right? RCO, the thing should never happen. Pen drive will enter the USB port only in one direction. Can you put the pen drive in other direction? No, you cannot do. Micro oven will shut down once we open the door only. OTP, beneficiary creation, all these are all error free. Look at this increase in chance of detection. Okay, when something happens, it will detect. Alarm for over temperature. In a micro oven, you should have an alarm. When there's a temperature high, it should immediately say, but still it will work, right? Alarm indication for seat belt is an increase of chance of detection. In your daily practice, ensure RCO and ICD is available. I can see in the lift there used to be a system where whenever there is near overload, it will give an alarm. What is that? That is a chance of detection. But if the lift doesn't move because of the overweight, then is a chance of occurrence of an incident. Do you understand? Error alerts to data entry person. Spell check indicates entry of a wrong spelling. These are all the RCO and ICD prevention. Please ensure this is followed. I've got some beautiful pictures for you in how it is used in the facilities and property management. Let's go one by one. Regular preventive maintenance, filter cleaning, coil cleaning to prevent chiller breakdown. These are all RCO prevention. If I would like to sit with you and write down what are all you can make an RCO prevention, reduce chance of occurrence and increase chance of detection. A proper training, regular inspection drills, these are all RCO prevention. Installation of flow meters, help desk tool, installed CC-Tech access control system to detect security breaches. These are all chance of detection. You have a lot of opportunity to improve RCO and ICD, and I would prefer you all to take a project to do an RCO and ICD prevention. The next, we're going five-way analysis. This is to find out what went wrong. There are five whys you need to do. Ask why repeatedly. Why? Any incident happens, ask five times why, you will get an answer. Everything don't stop with one why. Ask why repeatedly to find out. Define the problem clearly, then ask first why. Close the loop, make a root cause, and make a result. So I've got some examples. Problem statement: machine has stopped unexpectedly, causing downtime. Why? Find the cause, not just restart the operations. Right? There could be many ways. Do corrective actions. Right? So these are the five examples and start working on.